Right, the next part of the question is an equations of motion question. And I must say this is probably one of the most difficult questions I've ever seen in a GCSE physics paper. So if you can do this, you've been doing well. And thankfully, it was a couple of years ago, but hopefully they shouldn't give something like that again. But if they do, you've seen it before. So a bullet fired vertically from a pistol rises to a maximum height of 1875 metres above a planet in a time of 25 seconds. Calculate the average speed. So average speed is just distance over time, or total distance over time. And the total distance is 1875 divided by 25. And the average speed comes out to be 75. Just put it in here too. Now, in reality, what really happens, if it's fired vertically from a pistol, it's going to be affected by acceleration due to gravity, and it's going to slow down. So this is an average speed. So 1 mark for your answer, 2 marks for your numbers in your calculation, and 1 mark for your equation. Use your answer to part 1, or otherwise calculate the maximum speed of the bullet. Now there are 2 ways of doing this. You can either use equations of motion, well, but in both ways I suppose you're really using equations of motion, but you know that when you get an average it's the same as adding 2 numbers together and dividing by 2. So you know that it starts with a maximum velocity or speed and comes up to 0. So if I just draw that at the side, so you've got a maximum Vmax here, and it comes up to 0 here, V is equal to 0. So you know that if you're finding an average speed, so it's Vmax plus 0, because that's not up here, divided by 2. And so Vmax is just going to be equal to your average velocity or average speed, which is 75, multiplied by 2. So Vmax comes out to be 150. I'm going to do this the second way using equations of motion. If we use the equation S is equal to half U plus V times T, we know that the bullet travels a distance of 1875 metres. We don't know the initial velocity, and that's what we're looking for. We do know that the final velocity is 0, and we know that the time is 25 seconds. And so U is going to be equal to 1875 times 2 divided by 25. And it also comes out to be 150. It's only 3 marks for that, and I think part of the battle there is recognising where is Vmax, and Vmax is at the bottom. So if you did it this way, you get 1 mark for this, 1 mark for that, and 1 mark for some kind of equation like this. Or if you did it this way, you get 1 mark for your answer, 1 mark for your working out, and 1 mark for your equation that you use. The bullet then takes another 25 seconds to fall back to the planet's surface. Sketch a graph below to show the velocity of the bullet, how it changes during the entire motion. Label the graph P and write the significant numbers on the velocity axis. So we've got a maximum velocity of 150 here. And we know that it reaches 0 after 25 seconds. Now once it gets up there, and if we just go back to this diagram again, it's going to turn and come back down again. And it should, when it reaches the ground, it should have the same velocity that it started off with, except in a different direction, so it's negative. So we would expect it to finish off at a maximum velocity of minus 150. So you know that it's going from at time equals 0, from 150 up here up to 0. So therefore this graph is going to come down, and it's going to be a straight line because it's affected by a constant acceleration due to gravity of minus 10. And so the gradient of the graph should be minus 10. So, and it will just continue underneath the graph like this. and so it will end up at minus 150 by the time it's hit the ground again after a full 50 seconds. What is the average velocity of the bullet over the entire distance travelled? Now, its initial velocity was 150 and its final velocity is minus 150. And so no matter whether you take the total, your total velocity and divide it by 2, you get 0. Or if you wanted to talk about the fact that your total displacement, by the time you get back down to the ground again, your total displacement is 0. So we know that velocity is total displacement over time, or average velocity is total displacement over time. So the answer there is 0. Give a reason for your answer to part 5. And the easiest, or part 4, the easiest thing to do is just explain that average velocity is total displacement over time, but your total displacement is equal to 0. That'll get you your mark. Find the acceleration due to gravity in this planet. Now, it was really easy when you read this question to assume that the planet was the Earth, but it wasn't. So you have to find acceleration due to gravity. You can do it whatever way you want. You can use an equation of motion, or you can just use the gradient of the graph because it's a velocity time graph. So acceleration, I'm just going to use the gradient of the graph. You'll get exactly the same answer if you use v minus u over t, which is one of your equations of motion rearranged. And so you have minus 150, and I'm just taking it down to the 25. If we have a wee look here, just have a wee look there, you can see the 25. So minus 150 over 25, and that gives us minus 6. So the answer there, acceleration due to gravity in this planet, is 6. We got a minus because that was an upward motion whenever we took the gradient. On the graph opposite, sketch a graph to show how the velocity of the bullet would have changed with time if the same experiment had been carried out on Earth. Label the graph E. Now we know that g is equal to 10 on the Earth, and that means the gradient of that graph, the velocity time graph, should also be 10. So we have to have a wee look here and see where should our graph pass through. And that means we need a gradient of 10. So you have to have 150 divided by something to give you 10. So it has to be 15. So if I make a mark over here about 15 there, and our graph will look exactly the same, except it will go down through there and it will end much sooner. Something like this. And that's your new graph, and you must label it E or you might lose marks. So they'll give you marks there for having a steeper gradient is 1 mark. The same initial velocity and the same final velocity is another mark. And a 3rd mark for labelling it. If you don't label it, you will lose marks there. And you'll lose marks depending on what you've done here for the other graph. And it was supposed to be labelled P, so I would have lost the mark. But now we've got it labelled. Okay, so it's labelled P and this one's labelled E.